Not sure if Dean is on, but we'll get started here about 3 minutes, right at the top of the hour.
Hey, Wayne, this is Dean. I'm on.
Oh, good.
Okay, we'll go ahead and get started. Wayne, you want to start the recording?
It is on.
Okay, very good. Well, welcome everyone. Looks like we have about 25 participants on right now, and we had about, I think, 90 RSVPs. So we may have some others joining us here shortly. Before we kick it off, I do want to go over a few announcements and also just let everyone know who's on the call. So this is the ISA New Orleans section, but we have opened it up to other sections. We've got some very good participation from the Baton Rouge section, the Blue Bonnet section in Austin, Texas, Lafayette, Houston, and other sections across the U.S. and even across the world. We've got people on the call here from Brazil, Nigeria, Bangalore, and a few other places as well. So welcome to all who could attend today. We appreciate you taking time out of your day to listen to this presentation and learn a little more about the digital transformation of process and functional safety. Just a few announcements before we get going. I do want to announce to everyone that the ISA New Orleans section just celebrated its 75th birthday on April 11th. So some of you may recall ISA, the organization, the society became 75 years old or had the 75th anniversary last year in 2020. 2021 is our 75th birthday. So April 11th of 1946 is when we were incorporated as a section, and it was back then our first president was Horace Thompson with the Thompson Equipment Company. So we've been going strong for 75 years, and we appreciate everybody joining in here and participating and being a member of ISA. And if you're not a member, look into it and join our section. As a result of the 75th anniversary, we're launching a new Diamond sponsorship program. So those of you that have been sponsors in the past, we appreciate that. And that's been typically we charge $150 to be a sponsor for the New Orleans section. And that donation helps us put on these programs free of charge to members, and also helps with a lot of our outreach activities with FIRST Robotics and STEM programs and various functions we do in the area to promote automation as a profession. So we would encourage everyone to please sponsor ISA. And if you sponsor this year in 2021, you'll be able to sponsor for $75 instead of $150, and we will lock you in at that rate. So as long as you keep renewing, you can renew for $75 a year from here on out, and enjoy that benefit. And you'll be designated as one of our diamond sponsors in honor of our diamond anniversary. One other thing to mention here is if you haven't been on ISA Connect, I would encourage you, if you're a member, I would encourage you to go in there and check that out. The ISA Connect community, it's a community of the ISA membership that it has a very good technical forum, very lively technical forum and discussions with subject matter experts. People can pop in, pose a question on an application or something, some problem or something you're trying to research, and others in the community across the world, subject matter experts, can provide their comments and message back in the forum or private message you back as well. So we've seen a great adoption of the technical discussions inside of ISA Connect. So so again, I would encourage you to check it out. If you're not a member, you can see a little teaser of the technical forum. But in order to get access and be able to post within the forum, you need to be a member of ISA, and that's $130 a year for a professional member, $10 a year for a student member. One other announcement of events that are going on kind of related to this ISA Connect is in addition to ISA Connect going live back in August of last year, with the pandemic, ISA put on a lot of programs virtually over the last year and are continuing to do so. They've pivoted and put a lot of their training out as web type training, and they've also done a lot of these Connect meetings, which are it uses Zoom just like we're using today, and it's a way for different groups to get together, different divisions, different industries to get together and discuss topics. So there might be a topic discussion. There will be a facilitator, and people can join in and have conversations on topic and bring out certain points or ask questions. And so there's one geared towards the young professionals that's set up for April 28th. ISA defines a young professional as someone in the 35 years of age range, and you can identify yourself as a young professional, and you can reach out to other young professionals and connect on the ISA Connect platform. And the last announcement is that we will have a New Orleans Section Executive Committee meeting next week, April 29th at 5 p.m. We will also do that via Zoom. So I'll send a notice out to everyone on that. If you're not on the executive board and you're interested or just want to attend the meeting and see what we're up to, feel free to join us. So with that, I'm going to turn it over to our speaker today. David Hanson is a certified functional safety expert, and he's the director of the functional safety for SIS Silverstone, which is a partner company to Keystone Engineering. David's background is in instrumentation and controls, and he's been focused on functional safety since 2008. He founded and led Wood's Functional Safety Group and pioneered the development of new methods of effectively executing functional safety related projects and programs. His process and functional safety digital transformation experience includes the development of software roadmaps and implementation solutions for Mangan software, and also the development of process safety and digital analytics concepts for Worley. So SIS Silverstone is currently partnered with AE Shield, and they're a safety lifecycle management software company. And so David will be going over today and talking about the digitization of process and functional safety. So with that, I turn it over to you, David.
Thank you, Dean. Thank you, Wayne. Thank you for everybody around the world who is participating in this and listening. And thank you to ISA New Orleans for hosting this. And thank you for our partner company, Shield, and their parent company, Keystone, for helping develop this presentation. Shield developed a full safety lifecycle product, which is quite amazing, and working with them helped me make this presentation. So I'll bore you with some definitions to start with. There's a lot of them. I'm just touching on a few. The first being digitization. Digitization is conversion of analog information into digital. For us in the process industries, that's mostly scanning in paper documents and trying to digitize them. Second is digitalization. These all have many syllables. Digitalization is the process, or you can think of it as projects from moving to a digital business. So it's the installation of your software, it's the movement of data into the software, and the training of people, and it's the process of moving to a digital transformation. This term is quite unclear. That's my understanding of it. Next is digital transformation. Think of that as making use of digitalization. So taking all those completed projects and transforming the organization to get the maximum amount of benefit out of those systems. And this is a place where it often fails. Companies will do the digitalization, do the projects, but not change the organization and not get a lot of benefits out of it. An example of that is still requiring the use of paper reports for business printed out of the software packages and not using the power of the digital systems. Digital twins, you also hear that term often. Basically, it's computer models. Computer models are everywhere, and they're used to predict based off real data and also on theoretical data to predict the future. And all of us probably have digital twins through our use on social media, where social media companies and others have basically know what we like, what we do, who we are better than we are in many ways. There are many other terms, but we'll get into some of them as we progress through the presentation. A key term and a key concept is object-oriented programming or object-oriented principles. We'll look at an example for shopping. Let's say our company here is Mississippi Online Shopping Services. And Mississippi has objects, classes for the different types of products they're trying to sell. So in this case, they're trying to sell a defense attack robot, Mark I. And as children of that class, there are objects that represent serial numbers and individual objects or robots. As well, there's an object class called shopper. That's the millions of shoppers that use this system online. In this case, we have object, bill, and object chill, which are children of object class shoppers. So the advantage of object-oriented is it's a form of modeling. The real world is made up of objects, of things, and object-oriented programming duplicates the real world in that way. All these objects interact with each other in various ways. In this case, object Bill had purchased a robot, DARS 18709, and Jill has also purchased one. They've left reviews. We can see from Bill and Jill's interaction with the system what they viewed, other products they viewed, the reviews they've left, the returns of products, other purchases. And the object-oriented system captures every interaction between objects. The interactions here are very similar to what a brick and mortar store would experience. People come in, they look at products on the shelves, they purchase some, they send some back, they talk about it with the clerks. But none of that information is captured in the store. But in online, everything that happens, every event, every transaction, every interaction is captured forever. Also, these companies, Mississippi purchases data online from social networks. So not only do they know Bill's shopping habits and Jill's shopping habits, they know their politics, their friends and family, their occupations, pets, likes and dislikes, and much more. They know pretty much everything about Bill and Jill. As interactions occur and based off the knowledge of the purchase data, Mississippi is able to understand much more about their objects, the object classes, the products they're trying to sell. The AI that runs these systems, or this system, manipulates the pricing to find the optimum pricing level to ensure maximum profitability. And it knows which customers to target and which ones not. So in this case, the AI knows that it's going to avoid cat owners. It knows who the cat owners are based off the purchase data. It knows that cat owners tend to return the robots. So it's better for Mississippi to not market to Jill's of the world. But Bill, he's a dictator and a tyrant. He loves the attack robots. And so they're going to focus their marketing on Bill's and other dictators, and they know who they are based off the purchase data. So this is a very creepy example, but it's also shows you the power of objects and the power of collecting and learning. These systems learn, these systems adapt, these systems use analytics to make decisions that greatly benefit the organization. And this is the approach we are taking with functional safety, process safety, object-oriented, without the creepiness, but with the power. So let's say our system, our functional safety system, has an object class called HAZOP-LOPA. As children of that class, we have all of the scenarios for a facility or organization. In this case, we've got two scenarios: a tower overflow to compressor, liquid goes to the compressor, and you lose containment. And the second one is the tower floods and overpressures due to the tower seeing the pressure of the feed pumps. Additionally, we have another section of object classes, and these would be independent protection layers. We have a CIF 101 that shuts down the compressor on high level, a CIF 128 that shuts down the tower feed on high level, and a relief system. These objects interact with the risk objects. So now you know in the system exactly which protection layers are associated with what risk scenarios. So now through this connection, the software is able to determine the risks associated with each function. This is oversimplification. Normally you would have safeguards in here as well, but we're trying to make it understandable. And then we have another class, a third class called devices or inputs and outputs. We have a level transmitter, the level on the tower. We have an object access 145, which is the relay systems to the compressor shutdown. XV137 is the feed valve, and we have the relief system. And these objects also interact with the protection layers. We also have our higher level objects, the organization, process equipment, process units, facilities, maybe areas, business units, enterprise. All of this information connects and the system learns as the data is used, and more data is put into the system and it connects. We also have event data tied into maybe control systems or asset management systems. So we get diagnostics for each one of these instruments and bypass frequencies and rates and failure information from maybe maintenance systems, incident reports, activations. All of that is tied to the device input objects and also tied to other objects. We also can connect to additional systems like financial systems. Maybe we want to understand what the cost is of maintaining our safety, or the cost of adding new protection layers, or the cost of new designs. We can export and import information into projects, so we're using current and actual process safety data. Asset management systems for diagnostics, serial numbers, things like that. Process simulators for potentially running scenarios, determine the effects on safety of new designs or changes in production. We can run analytic systems which look for patterns and determine causes and consequences that humans probably would never see. On the left side, you have all the way up to the CEO's desk. So the CEO can look at his key performance indicators and see the overall risk performance of his facility. And maybe he's getting some red, so we can call Bill, his safety guy, to drill through the system and find through this connected information exactly what the risks are and how to resolve them. Likewise, somebody working in the plant is maybe looking at making a change to LT101. He can find that object quickly through searching it in the system. And he can see LT101, what functions it's used in. So these two. And yes, they're not independent because the level transmitter tied to both. And also the risk scenarios that level transmitter is affecting, which is both of these risk scenarios. So he knows if he's making a change to this transmitter, what the risks are. He knows if there's a failure on this transmitter, what to do about it, how soon he has to fix it, what the priority is. He knows if it has to be bypassed, what the effects of risks are. So these systems, these object-oriented interactive database systems, work from top to bottom, from the top level, executives, plant managers, all the way down to somebody working on an individual transmitter or valve. Once the data is in a system like this with connected databases, data objects, objects are a model, they simulate real life. Then data analytics systems can look for patterns and make recommendations that humans can't see because there's just too much data to deal with. So maybe in this case, the analytics discover that there's elevated risk throughout the system. And it finds that the issue through asset management systems, looking at model numbers, the issue is associated with model 146 level transmitters. And just by fixing this model of replacing this model of level transmitters, the risks for the entire organization are reduced back to a normal level. It takes us to analytics or machine learning. All of you, or probably anybody who works in the plant, is familiar with just the amount of data that comes from control systems or asset management systems is massive. And if you're like me, you find that most of that data is not usable because it's just overwhelming. So automatic systems like data analytics, machine learning can make use of the data automatically by looking for patterns. To make use of that data, we need better ways of connecting. So the old way, point-to-point connection, where this box connects only to that box, is not effective. There's a concept called a data lake, which is where all the data is accessible from one depository. And any of these systems can gather whatever data they can. And the data analytics AI system can look for patterns throughout the organization from this data lake. But really, data lake is these days is the cloud. Maybe the internet could be considered a data lake. So some theoretical cases from data analytics, possibly. The systems might see that there's elevated risks from seemingly random failures from different makes and models of transmitters. But the analytics could look at that and find patterns, find that actually it's not random. There's specific sets, serial number groups of transmitters in all types failing, and they're failing at times of high temperature because the analytics system also sees weather and location, and it sees model number and serial numbers from the asset management, and it sees elevated risk from the process safety. So that information could go to the vendors. They run their own analytics and discover that it's one specific type of capacitor used in different models, different manufacturers of transmitters that's causing the problem. Fix that, replace those transmitters, and the risk is now back to acceptable. Maybe another example is analytics discover that there's outlier risk scenarios. So a system could look at thousands, maybe hundreds of thousands of scenarios across a large organization and pick out those scenarios that are similar, like tower overfill and overpressure, and find the ones that are either risk ranked too high or too low. The ones that are risk ranked too low are actually elevated risks, and the ones that are too high, the facilities are spending too much money on maintenance and protection layers trying to mitigate those risks. So very powerful. Analytics is a very new thing, but once you have your data into a object-oriented type system, then it makes all of this possible. And in data lakes, it makes all of this possible. Digital transformation is definitely here in our personal lives. It affects how we make money. You talk to young people now, Gen Z, and it's amazing how they live. They grew up with the internet. They grew up online. They're making amazing amounts of money in the new computer game industry or the flourishing computer game industry. Everybody is a publisher, YouTube, Instagram, others. A lot of people are making money off that. Investing, we have the stonks, right? These online forums that talk up stocks, and these young people are on there all the time, and they're making a ton of money investing in stocks that are being pumped. And OnlyFans is girls making money selling pictures of themselves. Some of these things are kind of creepy, but it's a new way of making money, a new way of living that is so different than when I was a kid. It changes how we manage our money. We all bank online now. Money itself is changing. Cryptocurrency, if you've been watching what's going on with cryptocurrency, they're going through the roof. I would expect that crypto is going to replace paper money because crypto has a key element of currency, and that is it's limited in supply, unlike paper money. It's affecting how we spend our money, not only online shopping, but like we stated earlier, the AI is now telling us what we want. So we've gone from going online to find what we want to exactly what we want popping up on our phones. Definitely affects how we interact with each other. My neighbor's kids are about 10 and 8, and my neighbor says they don't want to go outside. Their friends are all online around the world. They have no interest in meeting their friends. They want to spend all their time online. And it changes how we govern. These computer models, these digital twins, climate change policy and COVID response are both set by computer models and predictions. And it's funny how humanity just believes these models and treats them like gods, and it's blasphemy to argue their results. So definitely digital has transformed our lives, our personal lives in a massive way. I'd say mostly for the good and some for the bad. Another important point here is that this is accessible from anything, the data clouds, the data lakes. We can access all the information we need, all of our feeds, all of our banking from any device we own, very accessible. Digital transformation is not here. So this is where we're at in our process industry, especially our process safety industries. We still largely work based off online documents, PDFs, Words, Excel. We have disconnected tools for functional safety. Typically, we use some kind of PHA-LOPA database tool, disconnected tool, which spits out a Word report. Then we might use Excel to create lists from the Word report. Then we'll use another disconnected SIL calculation tool to model the function to determine how much redundancy, what kind of instruments and kind of testing we need. And then we might model the functions again in another SRS safety requirement specification database to capture those requirements. We probably use a different action tracking software, probably a different MOC software, another document management software, maintenance management systems, maybe paper test results, control system logs, a lot of separate systems disconnected from each other, and they're difficult to access. We have many of these at Silverstone, and many of them require a physical dongle to activate, which means we have to go into the presence of the person who has the dongle and get that dongle to use it. So very difficult to get access to these limited licenses. You usually have to use them in the office. You can't just use them anywhere you're doing business. Very limited accessibility, very limited connectability. The information has to be replicated over and over and over again as it moves through the life cycle. So why is this transformation why is the digital transformation so slow? Let me try that again. Why is the digital transformation so slow for process industries? Well, first of all, the engineering companies who design these facilities and document them typically deliver PDF format documents. That's just the way it is, the way it's always been done. And it's also because of the deliverable mindset. Engineering companies get paid off deliverables, and those are typically PDF reports. Many of them are still just scanned in, so they'll take paper reports and scan them in so they can capture any handwritten comments or wet signatures, which means you can't even search. It's just pixels. There's definitely a hangover from financial system digital transformations. This is a hard presentation to make because of these odd, massive syllable words we use in this business. Hangover from financial system digital transformations, that might be SAP, where companies back in the 90s and early 2000s transformed from spreadsheets to enterprise financial systems. And it cost a lot more than expected, and it was more difficult than expected. And there's still a lot of headaches from that and hangovers from that. I can say that it wouldn't be the same now with this. I've done this kind of work and transformations and in different systems for different companies, and we've progressed a long way. We understand software a lot better. We understand databases a lot better. We understand how to import data a lot better than we did back in 1990s and 2000s, and the tools are much better. Consultants like myself make a lot of money the traditional way, papers, reports, clerk work. We get paid a lot of money to produce paper. And this is consultants not only outside of operating companies, but internal to operating companies. So there's definitely resistance to change there. Change, people are nervous about change. Today I'm an expert. If tomorrow we get a new massive enterprise software system, tomorrow I'm an amateur. It takes learning to learn how to work the new ways. So more resistance. IT departments are very cautious. They tend to have a mandate to slow the spread of database systems and software systems because they're getting inundated with these disconnected systems. Now that there's more of a focus on cybersecurity, all these various small software packages are a cybersecurity vulnerability. So it takes a lot to get an IT department to approve any new software. And we're dealing with process companies, energy companies, and the focus is not software, not like Google or Amazon or Facebook. Their focus is definitely software. Our industries are focused first on making energy, liquids, plastics, materials, and software is a secondary condition or a secondary consideration. And so software budgets are competing with many initiatives. not only for different competing software, but also for new heat exchangers that are corroded through, and or a new unit needs to expand to meet customer demand. So there's a lot of perhaps higher priorities for software. And there's a perception in the functional safety world that we are already safe. So why invest a lot of money in some new systems when we're already doing okay? People have this perception, it's human nature to think they're safe until an accident happens, or an accident recently happened. Ignorance is bliss. I've seen this. Software, this kind of software, connected object-oriented software, can reveal some significant hidden risks, which can be embarrassing for those in charge. And so there's some resistance because of that. I've seen it. And companies have invested in existing tools, the ones we mentioned, long lists of different software packages. They know how to use them. They've been using them for some time. They spent money on them. They're not so willing to throw those away and try something new. But despite all that, digital transformation is coming. In the last 4 years, I've talked to dozens of operating companies. And what I found is most are at least considering it, voicing interest. The majority have some budgets for digitally transforming process and functional safety. Some of those budgets are very small, some are significant. A lot were reduced during the COVID recession. Some have even massive ambitions for elaborate data lakes to consolidate all the data in one place and make maximum use of analytics. There are many functional safety lifecycle software pilot projects ongoing. And some companies have transformed facilities, but I don't know of any that are fully transformed as far as the enterprise goes. They have enterprise licenses, they have enterprise information, but I don't know of any that have all the facilities transformed. It takes a while. Major driver now is for high-level safety key performance indicators. This was a change. The executives are under pressure, or their executives are putting pressure on their safety people to understand what the risks are. They're responsible for the risks of the organizations, but they don't know what they are. So in order to have process safety KPIs that are effective, it either takes a large number of people, large amount of time each week or month to generate those KPIs semi-manually, or you have a software system that generates them automatically in real time. The COVID recession has cut some budgets, but overall it's increased interest in safety lifecycle software. Companies have had to reduce their staffing. They're looking for efficiencies now more than ever. And so that's now a driving push for the transformation. And governments are pushing for it as well. In cultures where government is more of a focus, there's Germany's Industry 4.0, which is focused on the fourth industrial revolution, which is basically digital transformation of their industries. Germany has a contract or agreement with China to help them with their 2030 agenda, which is very similar in industry to digitize and transform into a modern digital economy. And so what these major companies, these major countries do have a lot of influence around the countries around them and their customers. A word on cloud software. Microsoft Azure and Amazon Web Services are the biggest players. You've all heard about those. You've probably heard the term SaaS, software as a service. That's cloud. That's where a company would install their software on the cloud, create an instance for their clients, and the clients would use those instances perhaps around the world to use the software and get the advantages out of it. There's been a major shift in the last 4 years. 4 years ago, almost all of the customers I talked to wanted to install software behind their firewalls, cybersecurity concerns, access concerns. I'd say 90% felt that way. And now today, I'd say 90% want the software on the cloud. And there's a number of reasons for that. One is IT department reductions. It takes a lot to manage big enterprise systems with servers throughout their organizations connected, manage backups, manage software upgrades. These SaaS systems, web services, their business is protecting the data. They have server farms around the world so they can locate your system, your instance close to where you use it for speed of access. And they also back up your data globally. So if a local event happens, like a fire, revolution, earthquake, your data is still safe because it's in other places around the world. And it's hard for a company to do that, or an operating company to geolocate their data like that. Also, if a company locates their data behind the firewalls, it's very difficult for the software provider to access it. They basically have to have a company, an operating company machine to get through the firewalls. And it's difficult for their contractors or service contractors to access the software as well. So they have problems with updates, they have problems executing projects, they have troubleshooting when there's a problem. So this software as a service makes global enterprise software more viable, quicker, easier to manage. It's the data lake, and costs are declining for it. There's so much competition now between these two companies and others that there's been serious decline in software as a service, plus new technologies also driving down costs. There's risks in digital transformations. These projects can take time and effort, and they do fail, and resources are wasted if they do fail. And it also damages careers. If you're a guy championing a new software transformation, a digital transformation, and you've sold it all the way up the ladder to your CEO and your project fails, that's not good for your career. Conversely, if your project does succeed and you've digitally transformed the company, that would be very good for your career. If you transform into software like this, enterprise software, it makes all the risks visible, and it could move from negligence, which is just not knowing, to gross negligence when the information is available and the information, nobody's doing something about it, the risks remain elevated, nobody's taking care of it. So I recommend, if the transformation is completed, have a plan for addressing the risk, the discovered risks, like continuous improvement plan to show that, and actually execute the plan to show that there's no gross negligence there. Data reveals weaknesses. So if somebody can get into that data, they can see where all your process weaknesses are, what protection layers are, what the risk scenarios are, what needs to be defeated to cause an accident. And something that really disturbed me and disturbed a lot of operating company people based off my discussions online was this event where Amazon Web Services shut down Parler, a social media site. They gave them a few days to shut down their servers. That was based on political activism, based off the events at the Capitol. Turns out they said that the events at the Capitol were organized on Parler. Turns out it was Facebook, but it concerned a lot of people where a company could take political action against their data and shut them down, maybe especially for operating companies, global warming concerns. I don't think that's going to happen. I would bet that Amazon got an earful when they did this from their many customers saying, well, are we next? We're doing something you probably don't approve of either. So I think that's a one-up, but I would make sure that any contracts you have, that this is carefully contracted, that this can't happen. There is a difference with cloud business software. You own the software, the users own the software. Unlike Facebook, when you sign terms and conditions or any of the social media, when you sign that, they own your data. In this case, these companies don't. Why do these transformations fail? First is obvious one, software does not actually work. It's vaporware, you've heard that term. This is the easiest to overcome. You just test it. You do projects in stages to make sure it works before you go all in on the transformation. Another is that users think the software doesn't work, so they give up on it when it really does. One phrase we hear from customers that we always dread is, hey, can we have a demo access to the software so we can play with it? People log in, they play with it for 10 minutes, say, this doesn't work, and then give up on it. Any enterprise software that's able to transform your organization is going to have some complexity to it. Inadequate funding. It's not as expensive as you probably think, but it still requires adequate funding, or the type of data you get in the systems won't be complete, and then it won't be very usable. Those executing the transformation projects that understand the data. Data is not just so easy as pumping data into these systems. You have to know where to put the data. Some of the data is structured like a safety function. There's a hierarchy to it. So those that are executing your projects need to know how the data is actually, where it's located and how it's modeled. Software can be too difficult to use. Users aren't adequately trained or supported. Training is important, but I think support is more important. You might get trained and then not actually use the software for 2 months and you've forgotten what you've learned in training. So there needs to be somebody there who can support you after the training. Another is giving up before benefits are realized. So software is installed, some data is moved into it. It's a little bit difficult to work with, maybe a little bit confusing. And people think, well, I'm just not getting benefit out of this. I'm going to go back to the old ways. Where just like any object-oriented cloud software, the more you use it, the more benefits come from it. And so you got to stick with it to make it work. Just like the early Google Maps weren't very good, but the more people use them, the more the map system learned, and now they're just incredible. Another is software licensing. The software licenses should be set up so that everybody can access the software. If only a few access it, they're not going to get much enterprise benefits out of it. Big one is stop at digitalization, build the systems, move data, but the way systems are executed isn't changed. Still require paper reports, still require old systems. And so the benefits from the software is not realized. The digital transformation requires changing the organization to make maximum use of the new platforms. And incentivization, if managers are still incentivizing their workers to produce paper reports, to do things the old way, then they're going to do things the old way. There has to be incentive to use the new systems. And a big one is customization. Recommend highly against users trying to customize their software. You end up with an orphan system. Companies might do that if you pay them to do it, but then your system will be unique. You'll be difficult to support and won't enjoy the benefits that the main systems are enjoying as they continue to expand and upgrade. So the recommendation there is instead join users groups, influence the software company on what you want in the software, and you'll probably learn a lot by talking to other users in the user groups. And enterprise software can be political. It's affecting the whole organization, affecting the way you do business, and there can be a lot of resistance to implementing enterprise software. A lot of features in this kind of software. It's way too many to mention. A few here is being able to execute your whole life cycle in one platform, all connected data to facilitate risk studies, do SIL calculations, your SRS. SIL calculations and SRS are typically done at one time since they're both modeling the functions. Generate test procedures, operations and maintenance, documenting test results, all in one integrated platform with a single point of truth. So you have the data in one place. Risk information is in one place. It's not copied and mistakes aren't made moving it from one to the next. The architecture of the safety functions and protection layers all in one place. No mistakes moving it from one system to the next. The enterprise cloud accessibility means that KPIs can roll up through the organization, and also accessibility. The CEO can access any of the facilities if it's set up that way and see how any facilities, units, projects are performing. Likewise, if permissions are given, a project in one facility can access information from a project in another facility and make use of that information rather than reinventing the wheels again. These systems offer cloning. Cloning is where you basically copy maybe a whole compressor system or fired heater system, all of the functions that are part of it. It gives you dummy tag numbers, and you just change those tag numbers to the real ones you're using. Also can use these systems to create design templates. Corporate can build design templates, like how does a heater function, forced draft function, natural draft, a cat cracker. Design typical solutions for those, and then the organization can use those templates to build out their individual solutions. Sophisticated data importers make the digital transformation much easier. Data can be imported through CSV files typically. Mass editors. So let's say your turnaround is extending another year. You no longer have to rerun all of the SIL calculations that are part of that turnaround. You can just do a mass edit of all the test intervals and it gives you the new results just like that. There's a movement in industry towards automated SIS configuration. So since you have your cause and effects and your architectures of all your protection layers in the software, why not connect that to control system templates, function blocks, and generate configurations? Automatic data validation. So for example, you're trying to create a cell calculation and it's not working. Advanced systems will tell you exactly what's wrong, what data you're missing, what data it's assuming. So you don't have to spend a lot of time hunting around looking for the missing information. We talked about in the object-oriented section, the ability to connect from the device all the way up to equipment, units, functions, allows you to quickly assess what the effect is of a change or a fault in any of those devices, which also allows you to evaluate, manage a change, bypasses and failures. You can integrate with other systems, making use of that architecture. Control system data for bypasses, for events, for activations, demands, maintenance systems for tracking performance based off tests and failures, failure rate calculation for devices. And then lastly, data analytics, where analytics, machine learning systems look at where there's elevated risks and look for patterns in data to determine if there's a problem, what the problem is. Features are different than benefits. Benefits for this, number one is reduce risk. Truly move from I think to I know. So we've all heard that term many times, and you can get to I know at the end of a project when the documents are freshly generated, but they quickly become stale. Changes happen, the unit operations change, projects occur, and now we're back to I think. So a dynamic database that you use to do your projects in, that you're connected to your operation systems, will keep you in the I know phase. Reduce costs. By knowing what your risks are, you can allocate your resources to where they need to be allocated and not just guess. And also the efficiencies reduce costs. And then with improved safety and reduced risk, there's a definite correlation between that and improved business performance, productivity, profitability. Secondary to that, there's peace of mind. Executives, plant managers are responsible for the risks in their facilities and their enterprise. Without this software, they really don't know. There were cases, major accidents, where there were awards being handed out for safety just prior to the accident because the executives, they didn't know that they were elevated risk. So this software allows executives to know exactly what the risks are and make sure action is taken. Peace of mind. And then if your executives are happy, that's good for careers of those that made them happy. Consistency. By connecting data across an organization and to templates, you can ensure consistency so the wheel isn't reinvented and the best practice across the organization is implemented. Better predictions. These are all computer models. Models are used for predicting, for better decision-making, which is reduce risk, reduce cost, reduce performance. This scale on the right is supposed to symbolize balancing financial information with risk information. So industry has long had digitally transformed financial information, but on every financial decision has to be weighed against risk. But on the risk side, they don't know. It's a bunch of old reports. So by using this software, by digitizing, by digital transformation, you can now balance the information level so you can make better decisions around finances. Reduced cost and improved software performance. Reduced amount of software. Instead of having all these small software packages located around the organization on different machines, having a larger enterprise software makes management of that and accessibility much better. Then highly compensated personnel. I've been in operations in the SIS role, and I found without software, I had to spend most of my time looking for information, digging through old PDF, HAZOP, LOPA reports, looking at old cause and effects, trying to figure out what the effect is of a change or failure. And that's very tedious, and wasn't spending time bringing value while I was doing that. Well, having a digitally transformed system allows highly compensated people to actually bring benefit, to actually use the software to quickly find the information they need and make good decisions. And these systems accrue knowledge. The more they're used, the more data is attached to them. It doesn't forget anything. And instead of a static document, which once it's printed, once it's created, it never changes, the database system learns as it goes. And with all that, there's more effective allocation of resources, balance available information between financial and risk. Also, I want to add that young people, they expect to work in the digital realm. It'll be hard to hire them if you tell them that they'll be looking at paper reports and doing everything manually. So it's not only retaining current people, but attracting new young people. They'll be expecting some kind of software to work with. And that's to retain. And then lastly is increased asset value of facilities. We've seen an increase in trading and selling of whole facilities as business environment changes. And that's a risky to buy a business because you don't know what hidden process safety risks are. There's been lawsuits where a facility is purchased and then they find that there's actually a lot more risk and you have to spend a lot more money on mitigating the risk than they fully expected. If you're trying to sell your facility so you can react quickly to changing business environments, if you have your safety information in a database where all the risks are visible, that should increase the asset value of that facility. Also make your insurance carriers happy. So where will we be in 20 years? I don't know, but I don't expect that we'll be doing it this way in 20 years. There's a lot of movement in industry towards digitization because it's good, it's necessary, and I believe it's coming. It is coming. Okay, so that was a real quick overview of digitization, digital transformation. Are there questions?
David, thank you very much. Yeah, we've given all the participants the ability to unmute yourself. We've tried to address the questions in chat, so you can chat your question in or just unmute yourself and ask a question. If we have too many people unmuting at the same time, we can go to the raise your hand thing. But I think right now, if you have a question, just unmute yourself and ask away.
I see in the chat that some people are having audio problems. I hope that's not everybody.
It was just early on, so
Okay.
I think we're probably okay there. One question was asked about the presentation, making the presentation available. So, David, I believe you're okay with that. Is that correct?
Yeah.
So we will PDF your presentation. We will put it up on our archives. This session is also recorded, so the recording will be archived as well. So you can watch the recording again or go to a certain part that maybe you missed or you wanted to listen to again, and we keep those all posted on our archives. So not only this presentation, but all of our past presentations are loaded as well.
So there were a few comments on the YouTube chat. One was kind of earlier on in the presentation about what about MOC tie-in? I don't know if you had addressed that later on in the presentation.
Yeah, so MOC, just the fact that the data is visible and everything's connected to risk really facilitates MOC, and that's a good point. That would be another opportunity is tying MOC systems into software or including it in the software because MOC is about safety. And so safety software would be very beneficial for that.
Well, in the case of MOC as well, I guess looking at it in the object perspective, you may have an instance of an object, Rev 1 of a device, and you may have Rev 2 of a device as well, right? Also, a child of that object, or maybe as a property change or property changes for a different type of object.
Yeah, the way I'm used to seeing that done is you have as-built objects, which are supposed to be current. And then if you're making changes to those objects, you check them out in the software to projects. You execute the project. And then when you check the project back in, that new data becomes the new as-built object. That way you keep all the data in the system current. And you can look at the projects if you want to see the record of changes. There's a message.
Yep. The question, message about the PDHs. Yes, we will offer PDHs. So when you registered, we did have a question if you wanted a PDH. If you flagged that as yes, we'll automatically generate some PDHs and email them back to you at the address that you registered. If you didn't check yes and you still need one, just send me an email and we'll get you taken care of as far as a professional development hour for watching this. Okay, David, you got a question in chat from Sandy Vassar. You want to address that one?
Okay. All of these tools should significantly reduce the efforts for a big project, saving time, money, and resources. How far along are EPCs and system integrators in implementing these tools? Yeah, EPCs and system integrators, yes, more so. EPCs are slow to do it because they're waiting for customers to tell them what to do. They make lots of money doing things the old way. So there's not really much incentive to switch to these tools unless the clients either tell them to do it, or they're working on lump sum projects. That's just the honest answer. And there's different tools available. So if they focus on one tool, who's to say the client doesn't want a different one? So the philosophy for EPCs is, yeah, if you want me to use something, then tell me what you want to use and I'll use it.
Yeah, I think that's maybe a good point on one of your comments about why digital transformations fail. I mean, I think a lot of people get stuck in pilot purgatory. So, you know, they keep doing pilots and pilots and pilots, but never really pull the trigger on doing a project of making the transformation, or they keep evaluating because new things keep coming out. And so it's always, you know, am I making the right decision to jump on the right platform at this right time? It's analysis paralysis.
Yeah, that's definitely an issue. It's have to execute it like a project. You have your feed phase where you evaluate, and then you implement, and you have to cut the feed off at some point and say, okay, we're done evaluating. It's time to get some benefits out of the software.
Right, and if you did this in an object-oriented method, I mean, that probably lends itself to some portability in the future too. If you decided to switch platforms or take your data and go somewhere else, you know.
You own the data, and data is all data, text and numbers. So it's always possible to switch platforms, just take the data, move it to CSVs, and then re-import it into something else. That does happen.
Yeah. Can you talk a little bit to maybe some of the tie-ins for some of the older flat file systems or even structured data systems like an SAP, where you may want to take flat data or structured data and move it to objects?
Yeah, typically how it works, or one common way to do it is you would export from software, and it gives you the format, the flat file format, CSV format, and then you move data into that Excel, and it's now in the correct format because the structure came directly from the software. Then re-import that, and you have your software. There's also, companies also build application program interfaces. This allows real-time or semi-real-time data transfers rather than manually moving them from one system to the next through CSVs. So there's a lot of different ways to approach it.
All right, thank you.
There's a question from Kevin. Is there a change in people's opinions and perceptions with the saying, that is the way we've always done it, we'll continue in this way? Have you seen a change in people's old mentality on this? There's always people with that mentality in organizations, and there's always the innovators and the champions. And what has to happen is that within a company, an operating company, there's a sales process where the innovators need to be able to overcome the objections of the traditionalists. I'm seeing more of a shift now. Nobody wants to be last, Kevin. Nobody wants to be first. So they're not first anymore. People are implementing it. And if companies don't start doing something soon, they risk being last. So I think it's shifting away from, no, we're not going to do anything different too. Well, maybe we will.
I think you missed one go a little bit further back in the chat about the difference between data lakes and unified namespace.
Further back. I'm not seeing that one. What's the question?
Oh, maybe went to my must have came to me personally. So the question was the difference between a data lake and a unified namespace.
I have no idea.
Stump the expert, no problem. Well, I think you mentioned it earlier. Well, if anybody else out there has that answer, I'm not going to attempt it, but I'll probably embarrass myself.
Yeah, there's a lot of movement in the data space, and I haven't been able to keep up with it. I just understand the concepts. Data lakes, having data in one place where many systems can access it versus point to point. and
According to the
different ways to handle that technology.
speaks to maybe more federated data where you might have several lakes or different data sources that you're going to reference instead of moving it all to one place.
Yeah, that's probably more practical, but then less beneficial. People want to protect their data. They don't necessarily want it accessible. There's cybersecurity concerns. I don't know if industry will ever get to full data lakes, but we're getting closer. But as they put information on the cloud, they become lakes. So another question, adopting these tools, this is from Sandy. Adopting these tools by an EPC or a system integrator should be a great marketing tool. They should be able to demonstrate significant savings plus improved quality. Rework should be significantly reduced, which will benefit the EPC or systems integrator on a lump sum project. Yeah, I've talked to EPCs. I used to be part of one of them, and I've tried to go down this way, and there is interest. There is interest in improving efficiencies, but ultimately, if the client hasn't told us to do it, we don't really want to invest in something that the client might not want. So it's up to the operating companies to put pressure on the EPCs to want to make things more efficient, or maybe more lump sum projects. But they're probably not going to do it on their own. Why should they? They're making lots of money producing deliverables. And that's another thing is EPCs are so focused on deliverables, paper deliverables, reports. They have a hard time understanding what to do with data. How do you manage progress, track efficiencies around data? It's easy for documents. This document's 80% complete, this document's 60%. Data is a different mindset. And then but it's so beneficial, not only for the EPC, because you're doing things more efficiently, but also for the client, you're delivering a solution, a database ready to go for operations and maintenance, and not just a bunch of reports, which are a burden.
Looks like one more from the YouTube chat. And do you envision future digital systems to interface through APIs as more platforms become digital?
Yes. Yeah, customers are asking for that. They want APIs. They don't want to have to move data. They want data automatically moving from one system to the next. So there's a lot of effort by the software companies to build APIs, particularly to control system historians to gather activations, bypasses, things like that. And also from maintenance systems to capture failure results, test results. So definitely. Another question from Yassine. You have listed down an exhaustive list of reasons related to why people and organizations would resist digital transformation. Don't you think that we need more targeted business cases to address each of them? Yes. And Yassine, you're exactly right. There needs to be targeted business cases because champions within the organizations, operating companies need to be able to sell internally, and they need a business case for that. And that means dollars. And a kind of problem with that in a presentation like this is one, it becomes commercial, and two, it's specific to each customer because different customers have different needs and priorities. But that does definitely have to happen for each customer. Okay, so it looks like we're out of time. Thank you all. I really appreciate you listening. Thanks for the great questions. If you have any further questions, just contact me and I'd be happy to answer.
All right, and yep, thanks for everyone for attending. One thing I forgot to mention at the beginning was for those of you who may know, Mike Benbow passed away on April 12th. So Mike was a longtime member of ISA New Orleans section. His company, MS Benbow and Associates, was a strong supporter of our section, promoted encouraged a lot of people to join ISA, and as a result, a lot of those people who joined ISA won awards for their contributions to the society. So, so we miss Mike. He's a great man, and just wanted to mention that that he passed away on the 12th of April. With that, I will end the presentation, and we'll send a follow-up with the links to pull down the PDF of the presentation and to watch the presentation in our archive. Thanks for joining us.